geomagnetism. Now again, this topic in a syllabus is rather vague. बड़ा vague लिखा है that fundamentals of geomagnetism. Now fundamentals में God knows what they want, and there have been no questions asked. एक reference question है, that's all. So I'm downplaying this. I'll cover some topics, and my suggestion maintain with that itself. Okay. So your syllabus is fundamentals of geomagnetism. So quickly 1, 2, 3, 4 points. The first point here is that Earth behaves like a giant bar magnet. The Earth behaves like a giant bar magnet. Okay, a bar magnet, as in it is behaving as a giant dipole. Earth behaves like a giant bar magnet. It behaves like a giant dipole. Dipole means there is one north pole and there is one south pole. This is how the Earth behaves. It's one of the fundamental properties of the Earth itself. That's one. Second, this was discovered by a person called as William Gilbert. William Gilbert is not same as G.K. Gilbert. जब हम भी बताएं आपको Gilbert equilibrium theory is different. William Gilbert is much older. Okay, and William Gilbert discovered this by discovering certain magnetic rocks. Magnetic rocks discover किया था उन्होंने, and these rocks are called as lodestones. Lodestones are the magnetic rocks. So he said that Earth behaves like a giant bar magnet. It's a giant dipole magnet. Okay, very elementary. Achha. The third thing, there are certain facts about Earth's magnetism. Okay, one fact is that Earth's magnetic polarity, polarity is a reverse of Earth's geographic polarity. Okay, Earth's magnetic polarity is a reverse of Earth's geographic polarity. What I mean by this is, Earth का एक north pole है, the geographic north pole, and there is a geographic south pole. By the way, ये pole हैं क्या? Anybody can tell me? When I say geographic north and geographic south pole, वो जगह है क्या? Why? What is that pole? Anybody knows? Maybe you know it, but do not know how to. A reference point of what? How is that identified? A reference point of. So how do you explain it? Not wrong. Yes, you are. Where longitude meet, where there's gravity. Oh my God. Point of axis. Yes. London से पास करता है. London से और झुमरी तलैया से. Okay. पटियाला से और कहां से पास करता है बताओ? Okay. Point of tilted axis, west of true north. I mean, my God. So all of you have ideas. Some of them said yes. North Star. अर्थ पे ही चांद तारे. Okay. वो तो कहने के लिए कह देते हैं कि आपके लिए मैं चांद तारा ले आऊंगा. पापड़ टमाटर ले आओ. चांद तारा से हम क्या करेंगे? ठीक है. So essentially, Earth is rotating. Earth's rotation happens about an axis, where the axis is meeting the surface. This is called as the pole, and this is the pole. Okay, so this again, ये line imaginary है. Okay, some of you got that right. So Earth is spinning. Earth is spinning about some line. Okay, and where that line meets, that's the pole. So north wala is North Pole, south wala is South Pole. It is where Earth's rotation axis intersects at the surface. Okay, I mean something very elementary. I thought you should know it. Okay. Anyways, so Earth rotates like this. So what I'm saying is, this is the geographical North Pole, and the magnetic poles जो हैं, exactly they don't coincide. थोड़ा सा दूर है, यहाँ पर है और एक शायद यहाँ पर है. But this is the magnetic South Pole, and this is the magnetic North Pole. The polarity in terms of the magnetic field is opposite to that of the geographic field or geographic poles. Why? That's how Earth is. Okay, and this South Pole, this is in Canada. Canada, near an island called as Bathurst Island. Okay, the magnetic South Pole, जो north में है, it is in Canada, near a place called as Bathurst. It's near that. It's not exactly that. Near a place called as the Bathurst Island. Bathurst, Bathurst Island. और जो North Pole है, this is in Antarctica. Antarctica, near a place called as McMurdo Sound. It is in Antarctica, near the South Pole, a place called as McMurdo Sound. So that's one more fact. Okay, it is reversed, and the geographic poles, they do not coincide with the magnetic poles. They don't coincide with the magnetic poles. Okay, and if they don't coincide, का मतलब क्या है? This is the geographical axis, and this is the magnetic axis. Okay, they will have some angle between them. Okay, so next point, the third point. The third point, the angle between the magnetic axis and the geographical axis, okay, is called as the angle of declination. It's called as the angle of declination. Exactly, they don't coincide. There's a slight gap between them. It's called as the angle of declination. Yes, for all practical purpose, it is considered to be fixed around 10 to 11 degrees. But then just know, a fourth point add kar lo, okay, that the magnetic poles are known to shift, and the magnetic poles are known to shift slightly, because of which the declination angle can change. Because of which the declination angle can change. But a change is not dramatic change. Okay, so ये हल्का सा, ये जो north south pole है, ये हल्का सा ऐसे move कर सकता है. It is moving. Okay, because of this, this angle can change. Okay, but for all practical purpose, we may consider more or less it is around 10-11 degrees. So we just keep it as a constant. And that's one reason why we say that when you are traveling and you are using a magnetic compass for reaching the right place, you must apply what's called as the declination correction. Otherwise क्या होगा? आपका जो magnetic needle है, it is pointing here. So when you're traveling, it's possible you end up here and not here. You must apply some corrections so that you can reach here. Okay, that's why around here. Hence the magnetic compass, magnetic compass is not a reliable tool for navigation. Magnetic compass is not a reliable tool for navigation because it points to magnetic poles, and not the true north and south pole. It points to the magnetic poles and not the true north and south pole. Hence, travel using magnetic compass. Hence, travel using magnetic compass must allow for declination correction. If you're traveling using a magnetic compass, you must allow for declination correction. Okay, just some facts. So इसमें कोई ज़्यादा tricky science नहीं है. Just know these are some facts about the poles. Okay, the next fact. The earliest interpretation about Earth's geomagnetism was that there is an embedded bar magnet inside the interiors. Okay, एक बहुत पुराना आइडिया ये है. Why does Earth have this property? There was a concept that said that there is an embedded bar magnet. मतलब Earth ऐसे है और Earth के अंदर में एक magnet अंदर है. Okay, the south of which is here, the north is here. Therefore, this is South Pole and this is the North Pole. Okay, so we thought that there is an embedded, मतलब अंदर एक धसा हुआ है, embedded bar magnet inside the interiors. But now this idea is incorrect, because अगर ऐसा होता भी, even if we had such a magnet, it is so hot inside that this would have melted, and high temperatures they will lose their magnetism. So this is incorrect, because such a magnet cannot retain its properties, magnetic properties at high temperatures of the interiors. It cannot maintain its properties, okay, at the high temperatures of the interiors. तो melt कर जाएगा, and very high melting में any magnet will get destroyed. So this is not the right idea. And what we know now is, okay, number 5th point here is, now it is universally accepted that, next point, now it is universally accepted that Earth's magnetism is the consequence of the behavior and the arrangement of the Earth's core. The consequence of the behavior and the arrangement of the Earth's core. Earth का core कैसे है? There is okay, there is an outer core. The outer core is fluid, it is molten, it is rotating, and the inner core, this is solid. This is a molten outer core. The molten outer core will have loose electrons. They spin around an iron nickel rich inner core. and this is the iron nickel rich inner core. ये जो arrangement है, okay, these moving electrons create magnetic field. Okay, so the Earth's magnetism is because of the behavior and the arrangement of Earth's core. Arrangement of the Earth's core, in which we have a molten outer core. We have a molten outer core. This molten outer core has loose electrons, and the loose electrons, they spin around. They are spinning, they are moving around an iron nickel rich inner core. Iron and nickel rich inner core. Okay, और ये inner core है आपका solid one inner core iron nickel. ये जो arrangement है, this arrangement will create a magnetic field. So कुछ laws हैं, we have Fleming laws, Faraday's laws, ठीक है? So this is how the field is created. Yes, you're right, Charu. This mechanism is called as Earth's sustained a self dynamo effect. It's called as Earth's sustained self dynamo effect. Okay, it is a self-sustained dynamo. Okay, forget about the physics of this. You will get confused here. Okay, yes, there are some people who have discovered this. Okay, so Earth's sustained self dynamo effect. Self dynamo effect. Okay, there are electrons. ये जो electrons move कर रहे हैं, these moving electrons, they create the magnetic field. So just know this: if there's electric current which is moving around some iron core, it will create a magnet, and vice versa also. अगर magnetic field है around some core, it will create electricity. Okay, just that's all. We don't go into details of this one. ये dynamo, Ayman, याद कर लो. Dynamo क्या है, कैसे है? Okay, forget about it. I'm moving on now. Okay. Now, the sixth important point is that the magnetic field, field is till approximately more than 36,000 kilometers above the Earth's surface. The field is till approximately more than 36,000 kilometers above the surface, and this field has a very important role in blocking the harmful gamma rays. Gamma rays, a very important role in blocking harmful solar winds. Okay, they block and they protect the Earth. They have very important role in blocking the harmful gamma rays and solar winds. And just know this again, that the magnetic field of Earth is responsible for phenomena like something called as polar auroras. They are brilliant display of light. अगर आप North Pole के पास में है, you can see the lights. They're called as northern lights, southern lights, okay, boreal auroras. ठीक है? So auroras are light display in the northern hemisphere. In the northern poles में, they are called as aurora borealis. The word boreal means north. It's called as aurora borealis, and southern poles mein is called as aurora australis. Australis. It's incredible. अगर आप देखें कभी YouTube में हो या फिर otherwise photographs में, the light is brilliant. Okay, green, blue, reddish, yellow, orange. Okay, it's an incredible sight. Yes, I heard so. Recently, Ladakh में भी है. So what essentially happens in this is that the magnetic field, it interacts with the ions of the upper atmosphere. Interactions में the light is formed. Okay? So we have the field interacting with ions of the atmosphere, and they create the phenomena called as the polar auroras, aurora borealis and aurora australis. That's one phenomena. एक और phenomena है. We have something called as, just know this, okay? The magnetic field can interact with the solar winds and forms something called as Van Allen belts. Okay, ये बड़ा tricky होता है. In fact, crossing the Allen belts is also a very tricky thing for spacecrafts. Okay, there's a belt called as Van Allen belts. Okay, where the solar winds interacting with the magnetic field of Earth. So it's like Van Allen, VAN LLEN. So it's like this is the sun here. From the sun, there is some solar energy coming. This is the Earth here, and around the Earth, okay, there is this field of magnet, and the interaction happens. This force, it will turn it on one side. So ये ऐसे बन जाता है. It becomes something like this. ऐसे बन के, and then there's the inner belt and outer belt and so on. Okay, and the solar winds, they move like this. The solar winds, they move like this. Okay, just know these names. Okay, we don't have to get into details. Curious है to go back and look up into YouTube. You can see the graphics also. कि कैसे ये turn होता है. So it is a belt ऐसे shape लेकर. There are two type of belts. एक inner belt है, outer belt है. But we just need to know this name. This belt, which is a consequence of solar winds with the magnetic field. Okay, very elementary facts. I will not enter beyond this. Okay.